Today's book is the Usborne Practical Things to Do with a Microcomputer, Programs and Projects for Beginners. It was written by Judy Tatchell and Nick Cutler, beautifully illustrated throughout because it's Usborne, published in 1983, costing £1.99. It's a book about different stuff you can do with a computer. You've got programs to run, the standard sort of thing. But there's also 14 pages about building circuits and robots. We can look at the programs. I can't actually build you a robot, but I'll show you what there is, and maybe in the future, if I get real hardware, I can give it a go. Quizmaster. Here are two quiz programs for you to try out on your friends and family. One is a general knowledge quiz, and the other tests you with French. You can make up lots of other quizzes based on these programs, and there are some ideas for different subjects on the opposite page. I've just done the general knowledge quiz, not the French one. Other quiz ideas are animal families, food nationalities, famous people, and I've done some improvements which they suggest, which are adding comments to give you an opinion on your score. I've also added some more questions to the quiz. So let's have a look. So, one, the Quizmaster, and it asks us various questions. You've got to get the answer exactly right. It comes with 5 questions in the book. I did a few more because one of the options for checking the results is based on is the right answer to the wrong answer, and it won't work with an odd number. So I've added in some countries. For example, I noticed that it referred to West Germany. So I added in the Soviet Union and Czechoslovakia and Yugoslavia to keep with the theme. Washington DC was incorrect because it had to be Washington. Similarly, the capital of China is Peking, not Beijing, because they haven't changed over yet. But it's alright. Word processing and printing. You can buy word processing programs for most home computers. They allow you to use your computer like a typewriter. The words are displayed on the screen, and the computer lets you change them and check for spelling mistakes. When you are happy with your text, you can save it on tape or floppy disk and print it out using a printer. A printer connected to a computer can make paper copies of any text on the screen. Some can also print graphics. The paper copies are called printouts or hard copy. And there's a nice illustration of printers and printouts with pictures of perforated fanfold paper and paper rolls, and the description of the different types of printer you can get. And the cheap thermal printer, which is adequate for program listings but not always very clear. Dot matrix printers, which have better quality print. Teletypes, which are slow and noisy but are reliable and are quite cheap second hand. Daisy wheel printers are the best quality print but are expensive. All printers are slower than a computer. The good ones have a buffer, which stores messages from the computer. Printer prints them out in its own time. So we're going to look at a thank you letter generator, which could save you from writer's cramp after Christmas or a birthday. It is similar to the word processing programs using offices that send out standard letters and documents. Those are printed out on very good printers. They look like if they were individually typed. This one will. We're going to use the lprint command to print out a letter, so let's give it a go. So the thank you letter asks, first of all, who you're writing to. You're writing to ABBA. What was the present that ABBA gave us? ABBA, of course, gave us music. What is our name? Most famous song that ABBA did, possibly, was Waterloo, but in this case we're choosing to be Super Duper Tommy Cooper. And that's it. We get nothing on the screen because we're using lprint to print out to the ZX printer. This is the output from the printer, which was sent to the ZX printer from the Spectaculator emulator and then printed normally. In the 80s, there was a game called Lords of Midnight, and with a competition, if you won the game, you could send in proof, which was printouts of everything you did, every battle, and then win a prize. And that must have taken a huge amount of thermal paper at great expense. lprint does work, so I might be able to do list and print out my program listings like in the old days. Throughout the video, I'm going to intersperse the computing action with details about the practical things you can do. I don't unfortunately own a real Spectrum at the moment. I'm in negotiations with buying one on eBay, which is proving tricky. When I do get one, I'll hopefully do a follow-up video where I actually build some stuff. Downhill Racer Game. This game program shows one way in which you can create an impression of movement on the screen, using its upwards scrolling motion. When each line on the screen has been printed, the top line disappears and everything moves, or scrolls, up a line, leaving a blank line at the bottom for more printing. In the game, you have to ski down a slalom ski run without falling over the precipice. So I had some fun with this one and some problems too. There were a couple of minor syntax errors in the code. You're missing some semicolons. More importantly, in the code to say make it work for the spectrum, they refer to a scroll command. Scroll is a command on the ZX81 to make the screen scroll up slightly. It's not an available command on the spectrum. So what you do, you print at the bottom of the screen, then you print another line to force a scroll. Unfortunately, it then asks, do you want to scroll? Which generally ruins everything. You can get around it with a poke. So here we are. We're always at the bottom of the screen. You can move left, you can move right. If you hit one of the P's, you go over the edge, and then you die. It's not very fast, but then it's really easy to write. Inflation calculator. Inflation causes prices to rise, so you need more money to buy the same things as you did, say, a year ago. The current rate of inflation is often mentioned on the news and in newspapers. If you cannot find it there, you could try ringing up a bank. This program uses simple graphics to show the effect of inflation. It draws a chocolate bar, asks you for the rate of inflation, and then shows you the amount of chocolate you can buy for the same amount after inflation. After that, there's a similar version, but with a Coke bottle. Let's have a play. This is a chocolate bar. Each letter L represents a block, which is 1% of the bar. It's quite an effective graphic. This is the current inflation rate of July 2019, the current year, 2%. Let's try again with the inflation rate of the UK in 1983, the year of publication of the book, which was 4.6%, or 4.59, between friends. How much chocolate can we buy now? We lost a whole row. What about the year before, when the book was probably written, 1982? 8.61% in 1982. I'm impressed how effective the letter L's are to get the chocolate shape. Here we lost nearly 2 rows. Let's compare this with the Weimar Republic, October 1923. This was the inflation for the month of October, not the year, and it hit 29,500%, 21% daily. How much chocolate can we buy now? And that's none at all. I've amended the Coke bottle program to run through 10 iterations. We're now going through American inflation in the 1970s, starting at 5.6% in 1970, with a recession, going into wage price controls in 71, stagflation in 72, 8.3% for the end of the gold standard in 1973, Watergate in 1974 hit 12.3%, the stopgap monetary policy throughout the rest of the 70s, with the Federal Reserve raising rates to fight inflation, then lowering them to fight recession, which generally confused everybody. So the issue here is we can see that over time, the amount of Coke in your bottle is just dropping and dropping and dropping. This is the iterative effect of inflation is quite clear. The real value of the book is in the actual practical things to do with the microcomputer, actually building real circuits in the real world. It starts off with a very simple user switch. The idea is someone presses the switch and the computer does something. The little picture here is a cat presses on the switch and the computer says, "What's treading on my foot?" So it talks about the user port and how that connects to the circuit, and then a very simple program. It checks out what you're pressing and then runs from there. So the idea for that is once you've got that working, if the switch is closed, make a noise. For example, you might put it underneath your diary as an intruder alarm. Writing games programs. If you want to try writing your own games programs, you might find some of the routines in this one useful. For instance, the lines which print moving shapes, or the scorekeeping at the end. In the game, you are an absent-minded scientist who has been left behind after an exploratory visit to a far planet. Your fleet of spaceships has taken off, and you have time for 10 attempts to attract their attention with a laser signal before they set off for home. Let's have a look at it. away you go. It draws this, press the key to signal there's a pause, you press a button. Originally the pause was like 20 seconds long, and you stood there pressing keys, nothing happened. You press a key, it launches your laser signal, and your aim of the game is to try and hit the passing satellite spaceship thing. It doesn't clear when you start. It's a little bit frustrating because if it's right at the top, you have to press the key instantly, it appears. If it's lower down, you've got a bit more luck, and it's still quite tricky to hit. You get 10 goes. The higher up the spaceship is, the more points you get. You have to lead it, obviously, and if you miss, it's tough. So I've found some kind of flare. Yay! I successfully signalled that one. That's worth 140 points. If I was going to tune it to make it better, which I'm not going to do, I'd have it, you press the key to start. Yes. And they've gone home. I've got a score of 240, you need 300 to win. Also, you keep redrawing the bottom. Oh, nice. Can I hit this? No, it's that easy and I missed it. And your little spaceship, your signalling pod, I should say. And that just wastes a bit of time. But the actual scrolling is quite nice. The scores are top left. That's a hit. It was a successful signal, I should say. I'm worth 100 points. Can I get this one? Nope. That was tricky. I thought that was a hit, but obviously not quite. That's the signal. That's 240. Can I get this one? I might have a long walk home, like at the end of the adventure game. Waiting for the bus. Nope. I'm a rather foolish, absent-minded scientist, aren't I? Yay! They're picking you up. All the spaceships land! And I get to go home. The book wisely assumes that you are a beginner, so it gives you very clear instructions of what you need to buy. As an example, to make the simple circuit with the cat treading on the switch, you need to buy a 1K resistor, a micro switch of the push button sort, a single strand hookup wire, a plug and a lead to fit the user port, and a small breadboard, which is useful to build a circuit but not essential. That's called a Vero board. You can buy most of it cheaply in an electronics component shop or by mail order. You need to make sure you need to ask which wires connect to the 5 volt and the 0 volt pins in the user port, which wires to connect to them. And just note there'll be more things to buy on products on the other pages. As you progress to the ever more complicated projects, you will obviously need more and more electronic components. But it very clearly explains what you need before you set. They've got some programs here to illustrate that computers do what you tell them, no matter if it's stupid or not. There's one called Number Dunce, where you give it 2 numbers and it adds it together and gets it wrong in various bizarre ways. There's another one they do called Small Talk, which is the opposite of Number Dunce, in that it makes the computer seem reasonably intelligent. When you run it, it tries to have a chat with you. However, it only recognises yes and no. The rest of them are chosen from one of 14 answers. What it does do, though, whenever it puts an answer in, it makes a note that it's used it. Once it's used all the answers, it resets them and starts again. Okay, let's have a play. So a quick run through this. I've increased the frame rate to double the speed. Going through it a bit quicker. So essentially, it asks you to talk to it, you put a sentence in, and you get one of 14 answers. So I agree. Or yes. And then it randomly gets argumentative. But it's quite an effective, I think that they're called a leader program. So we had another one in Better Basic, which actually had some analysis of your answers and did various things based on what you said. And asked you random things about, do you want to be more rude, or what do you think about the blue whale? But here I'm just going off on some kind of tangent about the Commodore 64 moving into Commodore Schmidt-Lab, who, as you recall, was kidnapped in Batman the movie in the 1960s. which then led to Hounded Henchman, which has obviously confused the program. This actually, it could have seen the film. It was the book came out in 1983, so the film was available. They just certainly said yo ho ho. It was a sort of pirate theme. But a simple program, but interesting. It's not in artificial intelligence, but nice to chat to it. That'll do. The second project is an 8-way switch. I'm not going to cover it here, but move on to the third project, which is the binary light display project, in which you build a row of light-emitting diodes which light up in different patterns from the top left numbers on the keyboard. Each LED is connected to a bit in a location in the user port's memory, and is either on or off. So you need to buy 8 LEDs, 8 transistors of the type BC461, 8 82 ohm resistors with grey, red and black stripes, 8 2200 ohm 2.2K resistors with 3 red stripes, single strand hookup wire, plug in a lead and some Vero board. You build 8 separate LED circuits along the board, like the ones in the picture, and then you type in the program where the LEDs light up based on what you type in on the keyboard. That looks rather interesting, especially as it lights up. Good stuff. Debtors and creditors. People often complain when computers do stupid things, like sending out bills demanding instant payment of £0 and 0 pence. This is usually the fault of the program though. Try running the program below and see what happens if you type in 0, the amount of money owed. Can you improve the program? So this program's interesting. It's trying to show you about some common bugs. One of the bugs here is a logic error where there's an intermediate condition, which we shall see. There's also hints for better programs. You can improve the instructions in a program by adding extra print lines. For example, this program does not tell you to type in the amount in figures or to type in the currency amount in words, which can cause problems if you get it wrong. Let's have a look. Debtor program to produce letters demanding money or laughing at our creditors. So it starts off with Mr. McCorber, £20, annual income. He owes you £20, pay up now. So we go around again. Let's try and demand money from Scrooge McDuck. I think it's $10 million. Again, all working fine. Let's talk to Mr. Ben, and we owe him £100. Let's now talk to Mr. Uppity. There is no error checking here, so we put 0 in, and we get a letter designed for Mr. Nonsense. Horoscope generator. This program prints out a horoscope when someone types in their birthday. It shows how the computer uses arrays to store lists of information in a particular order, for instance the birth signs, month numbers and horoscopes. It doesn't do leap years very well, but it works about okay. It has some basic input verification really. You can't put a month in less than 1 or greater than 12. You can't have days less than 1 or days greater than 31. Essentially you put your date in, it works out your star sign based on the day of the year, which is reasonably clever. There's a number of arrays which it fills in, and it tells you your horoscope. So let's give it a go. Horoscope generator, let's give it a go. Give it the month in which you were born. I was born in December. Day of the month. Anniversary of the Tay Bridge disaster. I'm a Capricorn, correct. Take no notice of any horoscope, which is good. Just a bit of fun. Let's try some other great and good. Let's try Sir Clive himself. He was born in July the 30th. And Sir Clive is a Cancer, and his children will not believe in horoscopes. I don't know if Sir Clive has children or not. I've not checked it. And let's now try someone else just for fun. How about the great Rodney Zacks, writer of the Z80 Assembler book, who was born in February the 10th, Aquarius, You'll meet a dark, mysterious stranger. This is the big project. 6 pages. A robot to build. Find out how to build a computer-controlled robot vehicle. You plug it into the computer via the user port or input-output port. The robot has a bumper on its front, and when you start it up, you can negotiate an obstacle course on the floor. The program is supplied. You can follow a set route. You can draw a line to make pictures. This one is battery-powered, adapted for computer control, and there are 2 motors, 2 gearboxes, which are a pair of wheels. You need to build the circuit to control the robot, which is quite complicated, but the detailed instructions. You can buy different parts of the robot body, motors, gearboxes, wheels. You can buy a battery-powered motor-driven vehicle from a toy shop or model shop. Do not buy a radio control model, and make sure it has 2 motors which can drive the wheels independently forwards and back. All this is what you need to buy for the control circuit. Piece of variable, double pole changeover sub-miniature relays of varying sorts, transistors, wires, diodes. This is the proper stuff. Detailed list of what you need to connect to what, which poles you need to connect to which poles, and so on. Different pieces of wire and how you wire it all together with the double pole relay connecting to batteries and the motors. This stuff is really, really detailed. I could actually probably do it. If I had the stuff in front of me, you just follow what it does and it would probably work. There's also how you make the bumper for the robot. The idea is the switches on either side of the bumper. When it hits something, it detects it, knows to reverse and changes direction. For that, you need some cardboard, a bit of resistor, some sticky tape, and away you go. The program to control it, it's relatively simple. You need to work out 3 different numbers, which are going straight on, turning backwards, and stop. There's a program here which involves poking and peeking various points, change your direction randomly. And the last page of the book, it's an introduction to how to solder, involving safety first, how to solder things, and how to tin wire. This book is glorious. Computer poem. You can program the computer to pick words from a list stored in data statements and string them together in lines to look like poetry. The computer chooses words entirely at random, so usually it only turns out 1 or 2 good lines amongst a load of rubbish. Still, you can have fun changing the words in the data statement to try and make better poems or poems on different subjects. Run the program, and out pops a load of words. This is all very, very focused on food. Nothing here makes a great deal of sense. Perhaps it's some kind of beat generation poem generator. Run it again, got a couple of verbs here. There's a better poetry program in the Introduction to Computer Programming book, which I hope to cover at a later date, but it's just a bit of fun. You can change the data. I think now we should go over to our poetry department for a dramatic reading.
Into meat from, chew, think. Full fat is food, slurp fat was. Look, has into thirsty, hungry, full, drink, fat, eat, chewed, eat, look into, cook. Skinny was, has soup, think. Full slurp, bloated, thirsty, swallow, eat.
Thank you for watching this video about Usborne's practical things to do with a microcomputer. It's an interesting book. It's free to download on the Usborne website. The programs are okay. There's some quite interesting ones. I've not done all of them. Some of them are really useful information about how to use things in a practical manner, how to save stuff to disk, how to save stuff to tape, how to print. But as I said earlier in the video, the real meat and potatoes of the book is building the circuit. The last 14 pages about building circuits and then either controlling the computer with the circuits or controlling the circuits with the computer, leading up to that building of a robot. I don't have a real spectrum to play with. I'm not an electrician either, but I'm actually now intrigued by this. When I was a kid, I had a 30-in-1 electronic experiment kit that I actually found in my mum's garage the other week, which I'm now tempted to see if it still works. It's probably corroded to hell in the garage. But this book has actually inspired me to work out how these things work. Thank you for watching.